Hello, my name is Agus Lutanto. I come from Department of Mechanical Engineering, Universitas 11 Maret, Surakarta. It be pride for me and my team to present our review article with the title Review: Recent Development in the Design and Application of Magnetorheological Fluid in the Medical Field in the 7th International Conference on Industrial, Mechanical, Electrical, and Chemical Engineering ICIMECE 2021. Magnetorheological fluid, or we can call MR fluid, are smart material whose phase can change in a matter of milliseconds when exposed to a magnetic field. In the figure A, it can be seen that the MR fluid is between the two components, moving component and stationary component. The coil hasn't been electrified, so there is no magnetic field. Under this condition, the liquid phase of the MR fluid is called a Newtonian fluid. Whereas in the figure B, a magnetic field is activated around the MR fluid so that there is a phase change from liquid to semi-solid. MR fluids are categorized as smart material because they can change phases from Newtonian to non-Newtonian and vice versa quickly. Due to these unique properties, MR fluids have been extensively researched and applied in various fields, including mechanical engineering as a damper, brake, clutch, and etc. MR fluid has long been applied to car as a shock absorber filling since 2001 on several car brands. In addition, MR fluid is also quite promising in the medical field as a patient rehabilitation tool and for haptic devices. How to walk an average human seems so easy and done unconsciously. However, actually, when walking involves the work of complex limbs, there are 4 phases in moving one step, as shown in figure. Is initial contact, loading response, forward propulsion, and limb advancement. Not everyone can walk normally like stroke and foot drop sufferers. For this reason, rehabilitation devices are made, namely prosthetic and orthosis. In recent years, the development of MR fluid-based prosthetic and orthosis devices has shown an increasing trend. Prosthesis and orthosis are rehabilitation devices that are attached to the human body. The difference of both in the function and installation. The prosthesis replaces the missing limb, while the orthosis is used as a movement aid or as a support for the limb. In pictures, you can see the prosthesis and orthosis device installed on the patient. The upper is the picture of the orthosis device, while the bottom is prosthesis. On-orthosis devices require torque attention when the foot moves both in the dorsiflexion and plantar flexion direction. Dorsiflexion is a movement to bend the joint or reduce the angle between two bones when the sole moves forward. Plantar flexion is the opposite of dorsiflexion, which is the downward movement of the foot. For that need, MR brake actuator to produce braking torque. So torque achievement in MR orthosis become an important parameter. Some design has been made to maximize braking torque. In this slide, we show 2 examples of the MR brake design. The first design is multi-disc with a combination with double coil. The second design is drum type with serpentine fluke pad. Serpentine fluke pad is obtained from the systematic combination of magnetic and non-magnetic components around the rotor and casing. Magnetic fluke is forced to lead to a magnetic component. At the same time, the magnetic fluke is deflected by non-magnetic material so that the magnetic fluke reach the MR fluid is more optimal. The following pictures show a turning magnetic field with a variation of current 0.1 ampere, 1 ampere, and 2 ampere. The MR brake actuator on the linear MR AVO type works by dampening the translational movement of the rod connected to the ankle joint. Oba et al. Made a linear MR AVO design first, and then improved by Hassan et al. Improvement made included two things. First, the gap size was reduced to 0.5 mm from the previous 1 mm. Second, the bobbin core thickness was increased on the expense of coil turns to avoid saturation of the magnetic field. And third, we use a magnetic stake coil instead of a single stake coil. This change improved by braking power and enable 2 2.34 Newton per millimeter spring in this prototype compared to only 1 Newton per millimeter in the previous one. Linear MRAVO was also applied by Fu et al. For prosthesis. The innovation made is by placing many coil, or we can call multi-coil, to maximize the effective area along the channel. Fu et al. Named this actuator the MRPK, or a Magnetorheological damper-based prosthetic knee. Unlike most other MR dampers that use a lot of flow mode, the design applies a shear mode. Fu et al. Combine MRPK with sliding mode tracking control to control the shank's swing angle. As a result, this design is better in controlling the swing angle of the shank than the other design with on-off control. Next, ICIMECE et al. Made a breakthrough by making an MR prosthetic with the Vane MR brake design. In the last 2 decades, the Vane MR brake has been very rarely used. Before ICIMECE, the Vane MR brake was made by Kim and Oh in the 2001. The Vane rotor cannot rotate 360 degrees, so its move is limited. Vane MR brake is suitable for installing devices with low rotation and not continuously, for example rehabilitation devices such as prosthesis and orthosis. In terms of complexity, the Vane MR brake components are more straightforward than other types of MR brake. Both ICIMECE and Kim placed the coil outside the system to reduce the heat generated by the coil. Excessive heat in the MR field can reduce the performance of the MR fluid. Tactile feedback allows a person to create the sensation of touch without touching the object indirectly. Haptic devices including tactile feedback as the device involve tactile and kinesthetic feedback, which both become how to interact, understand, and feel something. Repulsive force produced by MR liquid on haptic devices can help the doctor when perform surgery and operation. Doctor can move the operating robot, feel the patient's organ without touching them directly, so that the operation process can be performed with more care. Arriving at the end of presentation, here we will give a conclusion. First, MR fluid as a smart material can be applied in the medical field as an orthosis, prosthesis, and haptic device. Second, several researchers made design innovation for orthosis, prosthetic, and haptic devices to meet several parameters, including damping torque and device size. This article was created as a reference for the development of devices based on magnetorheological fluid in the medical field. Okay, I think enough. I hope our presentation is useful and could contribute to the development of technology, especially magnetorheological in the medical field. Thank you.